Alright, so the next question we're looking at is from Chapter 6, and it's really similar to the one we did previously in Chapter 3 because we're still looking at the equation that relates force, pressure, and area. In this case, we're looking at determining the force needed as opposed to previously we looked at the pressure. So we need to use the equation force equals pressure times area. So something that we need to look at, and I can't stress this enough, is you always want to make sure that you're using the correct units. This seems this can be kind of challenging, but at the end of like the problem is that if it's not in the correct units, then you know that you did some sort of algebra error or whatever along the way. It happens. But this was a problem that we had quite a few questions on. So with force, we know that force needs to be in terms of pounds, which is something that the problem tells us in here. But that's something that we should also be able to figure out because in the force equals pressure times area, just jump ahead a little bit, but this is the pressure is given to us in terms of pounds per square inch. And then the area, the fluid area given is in square inches. So we know that the units cancel out if we multiply them together, leaving us in pounds, which is the unit that we want at the end of the day for this problem because force is in pounds. Also, just as a little note, how units are written. Pounds per square inch is the same as lb divided by inches squared. They mean the same thing, but just something to be aware of so it doesn't trip you up later. So in this particular problem, the pressure given was 150 pounds per square inch, and again the area was in 2 inches squared. So after multiplying these two things together, 150 times 2 is 300 pounds, which is the force that we need. I can't stress enough that we make sure that everything's in the correct units.